you know the velocity at a given time, and you know the initial velocity, you know what time it is. The time is time, v minus v zero over t. If I don't show you any arguments for v means v at time t, and t equals 0 is v at 0. So what the say is, you can measure time by having your own clock. The clock tells you what time it is. You can also say what time it is by seeing how fast the particle is moving. Because you know started with some speed. The change speed is some great J. So you can speed goes so and so now to the time ends. Time can be directly inferred from these quantities. So when you take that formula here, and you put in here that t at time t, you put this expression. So what will you get? You get an expression in which there is no t, you have these vanished favorites. I'm not going to waste your time by asking what happens if you put it in. I'll just tell you what happens. What happens is you would find the v squared. So it'll be 0 squared. That's how much thank you. How many people have seen this thing before? Okay, that's a lot. Look, I've only seen this at the moment. I have to go through some of the more standard material before we go to the more non-standard material. This is one very easy for you. There's not much I can do it. So if you draw a box, just drawing a box to you guys means important. So these are the two important things. I claim now. Remember, I have to one thing. How many of this you memorize? Suppose you've never seen this right? I'm saying that this is what the first formula tells you. So this is the second one. We're going to put on constant angular. If you want to take the derivative by 1 10 k, then you go down to square half. Something that gave me square. And I'm going to take the derivative. The other thing is something that take out 1 over that. So the point is, at the next one, when you see this, even at t equals 0, then that means the velocity, even though the acceleration is moving from point on to point on, acceleration gives you an extra sum, a quadratic line. Once you have got that, one over the velocity, then you have to get the t and put it in. But most people end up memorizing this. You use it sometimes. You can do 6 but you don't try to memorize it. So we're not going to do one standard problem that and themselves. We'll get to it. We're not going to formula the future of the right. So the problem I want to do is that meditation is a very big one. It's a one with numbers so I can do it from time to here's the problem. That is building. And it's going to be 15 meters high. And I'm going to throw something and it's going to go up and up. Something that's above. That's going to be a speed of 10 meters per second. So, last time, my thing is, you can ask me any question you want about this one. And I can ask where is t? Fraction of the long second normal time. I can ask anything about. But what I needed to do this problem was find each one. Because if you know some one given, there was one still a you know this example, the initial phase speed 15 meters, the initial velocity is 10. And for acceleration, I'm going to use minus g. And g plus simple, I'm going to call it minus 10. It's not a correct answer, it's right more but we don't want to use calculator, so we call it minus 10. Consequently, for this object, the position y, at any time t is going to be 15 plus 10t minus 5t squared. That is the full story of something. So if you have an example, we use it. So you cannot use the formula. Once it is around, fundamental premise that J was a constant of minus 9.8 or minus 10 is 1. That's not it. You can remember, once you get a formula, you've got to always remember the cells under the formula all the time. Like you use it beyond the validity, you get results that don't make any sense. Obviously, if you get an answer and it doesn't make sense, then you've got to go back and ask, how many ways, how many things can you find the assumption of the point and the acceleration to prove, as long as it's pretty important that the gravity can't get it wrong. Like it's under 1 year. So there, for example, it's where that happens. Yeah, but you have to have time. It's so obvious. It's not when it's so obvious that you may not know all the effects of the iteration and quite often you're using it. If you agree, it's a complete solution of this. When you use your I is more about you need a time. I'll tell you where it is. If you want to know how fast it's moving at a given time, if you want the velocity, I just take the derivative of fraction is 10 minus 10t. So let me take a couple of trivial questions. One can ask one question. How high does it go? How high will it rise? What height will it rise? So we're not going to go up and turn around and come down. We're going to see how high that is. So that is a tricky problem to see because you can take this formula here. You can see why if you don't see, but now we're not saying that. We don't know the time. And we don't know how high it's rising, so you can ask how am I supposed to deal with this problem. Then you put something else that you know in your mind is that the highest point is the point where it's either going up or going down. It's going up, that's not the highest point. It's going down, that's not the highest point. So the highest point, it cannot go up, it cannot go down. It's at the point where the velocity is 0. If you do that, let's find a particular time, t star, then 10 t star minus 10 is equal to 0. But t star is 1 second. So we know that it's going up for 1 second and it's going down in 1 second. Now we're done here, now you can ask, how high does it go? Let's go back here, y of 1. And then 1 is 15 plus 10 minus 5, which is 120 meters. By the way, you'll find that I make quite a lot of mistakes on the back. You're going to find out, here, when you start teaching, that when you get ready to go to the blackboard, I think this cannot think separately. It was correlation between your level of thinking and the prospect of the blackboard. So if you find any mistake, you've got to stop it. Why are you stopping? For two reasons. First of all, I'm very pleased when this happens. I'm very confident that I can do this under US. I cannot do it right every time. But if my students think I can make mistakes, they're following it, and they're not actually tell me. Secondly, as you go to the first part of the board, we take it as a part of the blackboard, we take it to the second part, you better if my school at the beginning and you don't see why, we'll have to do the whole thing again. I would ask you, when you follow the signal, you're active. Secondly, what's the matter? For example, if I'm stuck for like anything, and you guess what I'm going to say, I give me an idea. If I die and you stop, that's not a good sign. Okay? You're not keep going to this part because you can follow the logic. So, for example, I'm going to calculate next year, but this is not sure somebody else already. But this is not expected as well. You just watch me, because there's nothing like watching you open and you do some kind of thing. You have to check the tears, you got to die again, well, with your own flight struggle. I
まで時間がありますので、一旦すべてのドアを閉めます。ドア付近のお客様はご注意ください。ドアの開け閉めを行うときは、ドア横のボタンを押してください。
So in that notation, I want to ask what is y equal to 0. And ask when y is equal to 0, then I say 0 is 15 plus 10t minus 5t squared. Alright, cancelling the 5 everywhere, and taking the minus sign here, I get t squared minus 2t minus 3 equals 0. That's where it is wrong. So let's find out what the sign is. So t is then 2 plus or minus 4 plus 12 over 2, which is 2 plus or minus 4 over 2, which is minus 1 or 3. Okay, so you get two answers when it is wrong. So it's clear that we should pick 3. But you can ask, why is it giving me a second solution? Anybody have an idea why? Yes?
Because it shows a hydrometric size somewhere in here.
That's correct. So the answer was, if it was a full parabola, then we know t as a known before I set my clock to 0. Because for negative times, you're not bothering anybody. T equals 0 when I set the clock and measure time forward. But yesterday, t equals minus 1 day. Right? We don't have any trouble with negative times. So the point is, this equation does not know about the building. It doesn't know the whole solid answer. You went to the building and you blew up a rock. It knows nothing. What does the mathematics know? It knows that this particle, 15 at time 0, and the velocity of 10 at time 0, and this one is under gravity with an acceleration of minus 10. That's all it knows. If that's all it knows, then in that scenario, if there's no building or anything else, it continues to trajectory both forward in time and backward in time. And whatever seconds, 1 second before you put it at the end of the ground. What it means is, if you release the rock at that location 1 second before, with a certain speed that we can calculate, you would have ended up here, precisely the position and velocity it had in the logarithm. So sometimes the extra solution is very interesting. And you should always listen to the mathematics when you get extra solution. In fact, when the physicists of Dirac study a particle in relativistic quantum mechanics, he found the energy of a particle is connected to this momentum. This T is what we call momentum, and it's mass by this relation. So particle mass and momentum T has the energy. So you solve for the energy, you get two answers. Now your computation is to keep the first answer because you know energy is not good. Particles moving across some energy and that's it. But the mathematicians told Dirac you cannot ignore the negative energy solution because it tells you there's a second solution and you cannot throw them out. It turns out the second solution, the negative energy, was when the theory is telling you, okay, there are particles and there are antiparticles. And negative energy are properly interpreted with this antiparticle. So the equations are very smart. The way the physics works is you find some laws of motion, you mathematical form, you put it in initial conditions, whatever you solve the equations, and you answer them. You have to accept the answer. If there are new answers besides the one you're looking for, you got to think about what they mean. And that's one of the benefits of physics, because here's a person who's not looking for antiparticles. You're trying to spend electrons, but the theory said there are two roots in the quadratic equation, and the second root is mathematically accurate to the first one. You have to find the theory, and trying to adjust it so it can be incorporated to discover antiparticles. So all this is amazing too. You went to the problem, our eye or mind can see one class of solutions, but the math will tell you something about the solutions. And you got to respect it and understand and interpret the unwanted solutions. And this is a simple example that you can follow what the meaning of the second solution is. It means that the problem you pose is more than the answers that you present. Here it meant particles that was released around earlier, that it meant something much more interesting, namely antiparticles and accompanying particles. They will accompany particles surely as they release quadratic equation as two solutions. Alright, so now in this problem, we can do something slightly different. And that's use this expression here, and I will do that then. I'll stop for today. If you were asking questions like, how high does it go? But you don't ask when does it go to the highest point. Then you don't have to go through the whole process of finding the time at which it turns it out. And when it is the blackboard, then putting the time equal to 1 second into the formula. If the question of time is not explicitly brought up, then you should know that you have to use this formula. So how do we get it here? When we say at the top of the loop, then of course the constant of the velocity is 0. Therefore you say 0 squared equals the velocity squared plus times y minus 1 0. You solve for that, give by y minus 1 0 equals v0 squared over 2t. And you put in the v0 I gave you. It's 10 plus 100 over 20, which is 5 meters. So y equals 1 0 plus 1 meters, and that's the actual price. I think we got it somewhere else. We got the maximum height would be 20 meters. So I think the loop is given by the speed here. Given by the speed there equals v squared equals v0 squared plus 2 times minus g. Or y minus 1 0 minus y is 0. So y is minus is 15. You solve for that equation. Then you find the final velocity. So if time is not involved, you can do it that way. I want to write the last result in another way. Then I will stop, and that's pretty interesting because it tells you that use and abuse of calculus. I'm going to find for you this result using calculus in a different way. So from the calculus, we know d e dt is equal to a. So multiply both sides by v. Now you have to know from elementary calculus that 3 times d e dt is really d by dt of v squared over 2. Now I hope you guys know that with calculus we're going to take the derivative of a function of a function. Namely, v squared over 2 is a function of v, and v itself is a function of t. Then the rule for taking the derivative is first take the v derivative of this object. Then take the d of t, which is this one. On the right hand side, I'm going to write this a dx dt. Just much as standard. But here's what I'm going to do something which some of you are told never ever to do, which is to just cancel the dt's. You all know that when you do dy dx, you're not supposed to cancel that v. That's actually correct. You don't want to cancel the v in the derivative. But this happens to be completely legitimate. So I'm going to assume it's true, and I'll maybe take seconds and quite legitimate. What t means is, in a given time delta t, the change in this quantity true as long as both quantities are vanishingly small. They'll become more and more true. The delta x and delta v squared become vanishingly small in the limit of the sphere approaching 0. The true will be in fact equal. If delta x is defined at only 1 second, this will not be true because in the starting equation, delta x and delta t and delta v squared were all less than 3 infinitesimal. So don't hesitate to do manipulation of this time, and I will do them quite often. You gotta understand when it's okay and when it's not okay. What this means is, keep in mind delta t, if this quantity changes to some amount, and the same time delta t, that quantity changes to some amount, then keep it delta t equals some number, you equate the changes in the two quantities. Provided this is understood, the delta v squared over 2 is a change in v squared over 2. At the same time, there's a particle movement distance delta x. Then by adding the differences, we eliminate time and we get this final result. Alright, so if you go to your website today, you'll find that I assigned some problems, and you should try to do them today up to this chapter. Then next week, we'll do more complicated problems, then more motion in higher dimensions. I'll go through dimensions of 3 dimensions.
まもなく発車いたします。一旦すべてのドアを開きます。ドア付近のお客様はご注意ください。ドアが閉まります。ご注意ください。次は武蔵横手です。The next station is 武蔵横手。We will soon arrive at 武蔵横手。
syllabus is also available on this website. This website will become important to you should you choose to take this class. It will include the syllabus, which will occasionally be revised well in advance. Also, all of the class material will be on this site, including copies of the slides I'm presenting, including these slides right now, practice exams, and any details on the written assignments. So you need to use the website regularly to keep in touch with the course. Today will be a short class. What I just want to do today is orient you, tell you what this course is about. I know this is a shocking period. I want to give you a good sense of what the importance of this course. I want to go over the style of the classes, the evaluations, the meetings, and so on, and then give some examples of some of the specific topics that we'll be covering. So before we get started, I have to point out something a little bit unusual about this class. We're being filmed. This course is one of the 7 courses chosen to begin the Yale University Open Educational Resources Video Lecture Project. And what it means is that when the year is over, these videos will be available on the internet free for anybody who wants to see them. And ideally will be accessed by people from many different countries, some who do not normally have access to a university education. I think this is a good and honorable use of Yale's resources, and of course it's also part of Yale's plan for world domination. So because of this, a Yale University production team from Center Media Initiative is including people up there. The idea is that it should be as unobtrusive as possible, and the classroom experience should essentially be the same as if they're not there. So it's their intention to take the lectures, take me, and sometimes the slides, but not take your faces or voices, so we're not having you sign release forms. Two things. One thing is, personally, I have to remind myself not to use profanity. So if you want to talk about, do that. There's also another complexity. If you're in the front row, or the second row or the third row, it is possible that some part of your head, your back, or even your face might end up on film. If you are in a witness protection program, or you're some sort of fugitive, you probably don't want to sit in the front row. Even if you want to do something like that, that's fine. That's fine. Okay, we're ready. So, I'd like to introduce welcome people to this course, Introduction to Psychology. My name is Dr. Paul, I'm a professor of this course. And what this is going to be is a comprehensive introduction to the study of the human mind. So we're going to cover a very, very wide range of topics, including brain, silver, language, sex, memory, data, discuss racism, love, and many others. We're going to talk about things like the proper explanation for differences between men and women, the question of whether animals can learn language, the puzzle of what grows us out, the problem of why some of us eat too much and what we can do to stop, the question of why people go crazy in groups, research into whether you can trust your childhood memories, research into why some of us get depressed and others don't. The trial is there will be 2 lectures a week, as well as course meetings. Now, to do well in the course, you have to attend both the lectures and do the meetings. There will be some overlap. In some cases, the lectures will be quite linked to the meetings, but there will be some parts of the meetings that will not find your way to the lecture, and some lectures, some entire lectures, that will not connect at all to the meetings. So, to pursue this course properly, you have to do both. What this means is that if you miss a class, you can get notes. And so you can get this from a friend or from the person sitting next to you. The slides are going to be available online. So one of the things you don't have to do is you don't have to write this down. You take notes any way you choose. But if you don't get anything on there, it'll be available online. I'm going to post it in a format which will be black and white and easy to print out. So you don't have to worry about this. But again, attending to the slides is not a substitute for attending class. So the textbook, Peter Gray's Psychology, 5th edition, and there's also a collection of short readings. The Norton Reader edited by Gary Marcus. It's an excellent textbook, it's an excellent collection, and you should get them both. They're available at Labyrinth Bookstore on your street, or you get them online. I should note that last time I taught the course, I used the Marcus Reader, and when Professor Marcus Chun taught this course last semester, he used Peter Gray's 5th edition textbook. So there may be a lot of used copies floating around. Feel free to try to get one of those. The evaluation goes like this. There's a midterm, and there's a final. The final will not be held in the exam period, because of the obligations. It will be held the last day of class. The exams will be multiple choice and short answer, fill in the blank, that sort of thing. Trying for the exam, taking the exam online, you have to see how the exams work, and so on. There will also be review sessions. Starting at the beginning of the 3rd week of class, that is not next week, but the week after, on Monday, I'm going to put up a brief question, or set of questions, which you have to answer. And your answers need to be sent to your teaching fellow, your teaching fellow, assigned one, by Friday. This is not meant to be difficult. It's not meant to be more than 5-10 minutes of work. But the point of the question, 15-20 minutes of work. But the point of the question is to motivate people to keep up with the material and do the readings. These questions will be marked pass fail. I expect most everybody to pass all the questions. But it's just to keep you on track and keep you going. There's a book review, a short book review to be written towards near the end of the class. I'll give details about that later on in the semester. And there's also an experimental participation requirement. And next week I'll hand out a piece of paper describing the requirement. The point of the requirement is to give you all experience actually seeing what psychological research is about, as well as to give 100 subjects to experiment on. The issue sometimes comes up as to how to do well in the course. Here's how to do it. Attend all the classes, keep up with the meetings. Ideally, keep up the meetings before you come to class. And one thing I strongly suggest is to form some sort of study group, either formally or informally. Have people you can talk to when the exam, prior to the exams, or she's having next to her. I hope you know him. And in fact, what I'm going to do, not this class, because it's shopping period, I don't know who's coming next class or what, but I'll set up a few minutes prior to the beginning class for people to introduce themselves to the person next to them. So you have some sort of resource in the class. Now, this is a large class, and if you don't know anything about it, it's very honest. And some of you can pursue it that way, that's totally fine. But what I would suggest you do is establish some contact with us, either with me or with any of the teaching fellows, and I'll introduce the teaching fellows sometime next week. You can talk to us at the beginning or the end of class. Unless there's special circumstances, I always try to come at least 10 minutes early, and I will stay late to talk to people. You can come by during my office hours, which are on syllabus, and you can send me emails and appointments. I'm very willing to talk to students about intellectual ideas, of course problems, and so on. And if you see me at some point just on campus, you will be the resource. I love to meet people from this class. So again, I want to stress, you have the option of staying on in this class, but you also have the option of seeking out making some sort of contact with us. Okay. That's the formal stuff of the course. What's this course about? Unlike a lot of other courses, some people come to intro psychology with some unusual motivations. Maybe you're crazy and hope to become less crazy. Maybe you want to learn how to study better, improve your sex life, interpret your dreams, and win friends and influence people. Those are not necessarily really bad reason to think this course, and the perception of the second part, this course might actually tell you over some of these things. The study of scientific psychology has a lot of these things real world relevant, real problems that we face in our everyday lives. And when a lot of things come up, I might try to stress them and make you try to think of the extent to which the laboratory research I'm talking about can affect your everyday life. How you study, how you interact with people, how you try to persuade somebody of something else, what sort of therapy, what's best for you. But the general goals of the book are actually, I think, even more interesting than that.